In today's lesson, we're going to learn about constructions. We're going to start off by looking at some of the equipment that we have in our math sets, some of which we have already used and others might be new. To begin with, we will look at the ruler. When we are asked to do constructions, we are sometimes asked to use a straight edge. And this means that we could use the ruler, or we could use any of the other pieces of equipment with a seemingly straight edge. We have two set squares, a set square. They both have straight edges. We could use those. And the protractor also has a straight edge. So it's important to note that we don't really require a ruler if we are drawing a construction. When we look at the two set squares, it's quite handy to have the two, especially if we are asked to draw some special angles. And special angles being 90 degrees, which we know is a right angle. And if you notice that both of your set squares have right angles, so there is a 90-degree corner on both this set square and this set square too. So our corner of our page will fit absolutely perfectly, there we go, for either of those set squares, making it this, a 90-degree right angle. There we go. Ooh. Okay, now the other angles on these set squares are different. If we take this one, for example, then the other two vertices, so a vertex, if you remember, is where two line segments or lines, or if it's a polygon like a triangle like this, where the sides, two sides meet. These two are both equal in measurement, and they are both 45 degrees. So what type of triangle is our set square? If we have one 90-degree edge and we can see the square indicating at the top there that it is a right angle, and the other two are both 45 degrees. It's an isosceles triangle. So if we wanted to draw 45 degrees, we could simply use this set square, and we know that if we trace our pencil very neatly along this edge and this edge too, we have 45 degrees. And likewise, our other set square, you can see quite clearly that it is neither an isosceles triangle nor an equilateral. You see the three lengths of the sides are much different in measurement. We still have the 90-degree here, but these two angles are also special and come up quite often, so they're handy to know too. And they're 30 degrees and 60 degrees. We've already looked at using our protractors before. Let's see if you can remember some of the parts of it. Can you remember what the intersection, the cross in the middle here is called? It's called the center mark. And we have the baseline running across the bottom. And we can use this then to measure angles going in both directions. And depending on what direction we're measuring the angle, whether from left to right, will tell us on whether we're using the inner or the outer scale. So let's just have a quick recap on this, and let's measure the degrees of our angle BAC. So if you recall, we need to place the center mark exactly onto the vertex, and then ensure that the baseline is exactly in line with our arm of our angle. Whichever zero our arm passes through, so you can see it's passing the number 0 and the 180. Well, we want it to pass through the 0, and that means we're going to be counting up from 0. If you imagine that the angle has increased from a null angle and it's risen up. So we're going to measure from 0 And you can see that our angle is 1 degree more than this larger mark, which we know indicates 5 in between the previous printed number. So it's 0, 5, 10, 15, 20, 25, 30. This little mark is 35, so that makes our angle 36 degrees. Our next piece of equipment is our compass. Different parts of the compass are called different things. We have the needle point. We've got a steady arm, and that's because we need to keep this one quite steady. Then we have the adjustable arm, which, as it suggests, can be adjusted, so we can move this, make it smaller or bigger, depending on how big we want to draw either a circle or an arc. At the top then, we have the handle. Now, when we are using a compass, it's really important that we have a very sharp pencil, and that when we place it inside the compass, that we align the tip of the pencil exactly with the tip of the needle when the arms are both closed. As you can see, the point of my needle and my pencil are both perfectly in line. Now, it's really important that when we're using the compass, that it's not going to slip when we use it. Now, you'll notice that when you open it, the first stages of opening it, it can be quite loose and it might move around a bit too much. So, providing we have a bit of flexibility, we don't need it to be a very small circle, it's better to open it to where it gets a little bit stiffer and therefore it's less likely to slip. Now, you can see that there is a screw up here. You can always use a screwdriver and tighten it if you feel that your compass is slipping a little bit too much. It might just need a little bit of a tightening. So as we said, compasses can be used to draw circles or to draw an arc. Now, an arc is just a small section of a circle. And there we have it. Just a small section if I sweep around. So I keep my needle point still and swoop around, not going all the way, just a small amount, and that's called an arc. It's just a small part of the circumference, which we know is the correct name for a perimeter of a circle, so just a small bit of the edge. And then if we continue to turn it around, we can have an entire circle. In order for our circle to be accurate, we need to make sure that we don't move the needle point once we start drawing our circle, and that we keep one hand then firmly holding the page down so that the page doesn't move either. And not too hard that it damages our paper, and we continue to move around, again making sure that the circle is complete. The location of where the needle point was becomes the origin, the centre of our circle. Constrictions are not like sketches. A sketch is a rough drawing, which isn't to scale and it isn't correct with measurements. A construction must be completely accurate. All vertices must line up perfectly, all lines be straight and passing completely through points. Whenever you see a question in an exam asking you to make a construction, you must be very accurate and remember to use your correct maths equipment. In this lesson, we're going to learn construction 1, and that's called the bisector of an angle. Now, in order to be able to draw this in an exam, it's important that we know what a bisector means. If we bisect something, it means that we are cutting it, but not just cutting it anywhere, we're cutting it into exactly 2 equal parts. Hence the word bi meaning 2, and it sounds a little bit like dissect, which you may have heard of before, which would be to cut something open. So together, bisect means to cut something into 2, and they must be of equal measurements. Now, if we are creating a bisector, that means that we are cutting, and in this case it's a bisector of an angle, that we are going to be cutting an angle into two exact halves. And in an exam, you will be given an existing original angle, such as the one that we measured earlier when we worked out that the measurement of the angle BAC, B to A to C, so this measurement here, we worked out was 36 degrees. You'll be given an angle, and construction 1 then is asking us to cut this into exactly 2 parts. So in effect, we're going to be creating 2 angles, which will be how many degrees each? Did you say 18 degrees? Then you'd be correct. However, we will not be using a protractor. With constructions, we have to show our workings. They're called construction lines, to show the examiner that we have used the correct method. For construction 1, we will be needing the compass and a straight edge. And I'm going to be using the ruler as my straight edge. Okay, so let's get going. So the first step is to sweep across both arms of the angle. So there's one arm, there's the second arm, with the needle of the compass on the vertex. So that would be the point A in this diagram. Now that means that we're going to have to make sure that our width of our compass, which is the distance between the needle point and the point of the pencil, is not bigger than the angle's arms itself. If I was to have it this big and sweep across, it wouldn't actually cross the 2 angles. It's at the 2 arms. It's too wide. And it's hard to be accurate when it's too wide. And if we don't have it open wide enough, so we have it very, very small like this, then our arcs that we create are going to be so close to the vertex that we're not going to have much space for our workings, and it's going to make life difficult for us. So we want somewhere in the middle. So I roughly want to have my arc somewhere sweeping across like this. So I'll open my compass to something about this. So I have my needle point exactly on the vertex, and I'm going to start either above or below. I'm starting above, and I'm going to sweep across both arms of my angle, creating an arc. Now in constructions, it's really important that we label any intersections, that means crossings, that we create. And here we have created 2, one here and one here. And we're going to be using them in the next step. So we're going to label them like all points with a capital letter, and we're going to use ones that we haven't already used. So rather than A, B and C, you can pick anything you like. A lot of examples might use X and Y, but I'm going to use D and E. Now, from this moment on, it's really important that if I change the compass width now, that then I stick with it. So why would I need to change the width? Well, I would need to change the width if my distance between these 2 points that I've just created is larger than the width of my compass, but as you can see, it's much smaller, so I won't need to change my width. Now, what we're going to do now is we are going to put our needle point on our 2 new points that we've created in turn, one at a time, and sweep in between the arms of our angle. And what will happen is that they will create a crossover. So let's have a look and see it. So first, I've got my point on D, and I'm sweeping in between my 2 arms. Then I'm going to change and put my point on E, again remembering to be really accurate, and sweeping in between my 2 arms. And there's that crossover that we talked about. And again, we've created an intersection, a crossing of these 2 construction lines. These are our workings. And we therefore need to very, very slightly mark our intersection. And again, we're going to label it. and I'm going to pick F. Now, I'm not going to draw it quite so close to the point because we're going to be actually putting a line or a ray through this point in a moment. So I've just put it slightly to the side so it won't be in the way. Now, our last step is to connect our original vertex A and the new intersection that we have just created using our straight edge. And this again is where it's really important to make sure your ruler is lined up properly. So we rule the line across, and there we have it. We have taken our original angle BAC and we have created the bisector. We've cut it into 2 equal angles, and we can check that we are correct using our compass. So we can line up our center mark and see which 0 our baseline is traveling through. It's the inner scale, and I can see there exactly there is 15, 16, 17, 18 degrees, exactly as we had decided earlier. What's really, really important about all constructions is that you never rub out your workings. So these arcs, these workings, they are part of the construction. And if you were to rub them out so that you just had your angle and your line, you wouldn't get full marks. It may suggest to the examiner that you had used the protractor instead of the compass and the straight edge. Okay, so I'm going to want you to get your notes copy out now. And it's a new chapter. It's chapter 5, so start a brand new page, and you will want to use, if it's a small copy, a whole page for this one example. And you can put the heading then construction 1, and the title is a bisector of any given angle using only a compass and a straight edge. So you can pause the video here for a moment and put your title, your sentence explaining like it's shown on the screen, and also then I would like you to draw the original angle. And if you imagine that this yellow box is like your page, so you can turn your page to the side if you like, but it needs to be quite a good size, and again nice and neat and accurate. Use your rulers and sharp pencils. So create your original angle, and in this case this one's ABC. And then once you have created your penciled angle with pen end points and vertex, then you can press play again, and I would like you to create your construction of the bisector step by step. So with each step you can pause the video and complete that step yourself in your notes copy. Using B as a vertex, you're going to draw arcs to cut the arms of the angle, sweeping across, and you label those points. Making sure then that your compass is wide enough, you're going to put your point on one of those new points, sweep in the middle, and then without changing the compass width, do the same for the other point. You're going to mark where the arcs meet in the middle, and then connect that to our original vertex. And there's the full steps. Can I ask you now to pause the video once you've completed the construction, if you could please write down the steps. So in your notes copy you should have the diagram and the steps to go with it. I just wanted to show you one of the issues that students have with this. They might have their arms. Now you'll notice in the diagram used on the screen there was a gap in the middle. It doesn't matter whether you lift or don't press down, but making sure your needle stays on the vertex, or you can just complete the sweep both across, it doesn't matter. Now, one of the mistakes that a lot of students make is that they find that the problem is that their compass is not open wide enough. But so this is what happens when they don't have the compass open wide enough. I sweep round on one, sweep round with the other, and they don't cross. But it's a very easy fix. A lot of people think, oh, we've gone wrong, but it just means that their compass width wasn't open big enough for the next step. So it has to be open the same amount when creating this one arc, which is sometimes why it's a good idea to just not stop and just create the first arc all in one. Then you can change your compass width as long as you keep it the same when you're using across from this point, sweeping around, and across from this one, so that they do actually, intersect then. So it's almost like they're in pairs. You can open your compass, keep it the same and the same, then you can change it if you want, as long as it's the same, and then it stays the same on this side, like in 2 sets of 2. So let's revise that again. So we have a given angle. It may be not quite as obvious where the bottom is. So don't forget, in your exam, you can turn your page so that it looks a little bit easier to work with. Place the compass needle on your vertex, in this case point B, and draw an arc of the same width, so using the same compass width measurement across both the arms of the angle. Then you will label the points of intersection at those arcs, for example, X and Y. Then lift the compass, put the needle on the first new intersection point you created, like X, and draw an arc in the middle of the 2 original arms, making sure that the compass width is more than the distance between the 2. Without changing that compass width, then do the same on the other point, so on point Y, and that will then overlap the other arc. Mark the point where the 2 meet, and then use the straight edge to draw a ray from the vertex through to that point of intersection on the overlapping arcs. And that will be the bisector of your original angle. So step 1, compass on the vertex, arc across both arms, label those points X and Y. Next, needle on one of the points and create an arc in between the 2 original arms. Then compass point on the other new point. Again, arc in the middle. They now overlap, and we can put a line straight through from the vertex, passing through the point we created in the overlapping arms. And what we have here is 2 equal angles in measurement, which will be exactly half. Both of them will be half of the original angle.